So in Chapter P, Section 3 now, we're going to do a ton of examples on multiplying polynomials and special products. Okay, so special products are patterns, and some of them I think are super important, and some of them I think you can just do it the long way, and I'll kind of go over it. Now, there's some special products that have patterns, and if you can identify the patterns, you can actually do the work in less time. It's like a permanent, really like a cool shortcut, okay? Now, I will tell you that the only ones where I think the pattern really matters really is this one. This is the one we use all the time, and this is the one that I kind of really like the pattern. But I will tell you that these special products are not really necessary for multiplication, because if I have a plus b times a minus b, I can always FOIL, and I can get my answer. And I can FOIL for this one too, because this is a plus b times a plus b. This is a minus b times a minus b. So I can always FOIL. This one is 3 terms. You know, it's like a plus b times a plus b times a plus b, and it's a longer process, but I can always do all of these the long way and multiply, okay? The problem is that, again, if you memorize the patterns, you sometimes can save some time. I'm going to solve the upcoming problems both ways. I'm going to pick and choose. But why is this one important? This one's really important because it is a great shortcut. And notice, if I FOIL this and I do first times first, I get a squared. When I do outer times outer, I get minus ab. When I do inner times inner, I get plus ab. And when I do last times last, I get minus b squared. And in this particular pattern, when the only thing that's different between the two is one is a plus and one is a minus, what happens is the middles will always cancel out. And so if you just do a squared minus b squared, you get the answer. So memorizing it avoids having to multiply it out and then cancel it anyway. Now, the issue is it's not so important to memorize this pattern for multiplication. However, when we move forward to the next sections and we're factoring, it is important to recognize that when you have a factor like this, it came from these two binomials. And so when you work it backwards, it's kind of essential. So again, it's kind of important, more for factoring than for multiplying, but it's just one that we use a lot, okay? These other ones, a plus b times a plus b, again, if you just FOILed it and you just did, you know, first times first, outer times outer, inner times inner, and last times last, you see that it's a squared plus 2 times ab plus b squared. And yes, that's a cute little pattern and everything. Yes, we got the answer. But again, I don't know that it's super important. If it's a minus sign, the only thing that changes is this is a minus 2ab in the middle. And the last ones, I'm not really sure if I really would utilize that too much. But again, I'm going to walk you through how it comes up, and then at least you can understand it, and because it looks pretty confusing here. And what it is you take the first term cubed and the second term to the 0 power. Okay? Now, mind you, this is the plus one. Everything in the plus one is a plus. So then you're going to do plus, and since this is not the first term, everything's going to have this 3 here, and then you're going to lower the a to squared, and you're going to raise the b to the 0 up. So the a's go down by 1, and the b's go up by 1 every time. So 3, a to the first, b to the second, and then the last term, again, you're not going to put a coefficient in front. You're going to have a to the 0, b to the third, and recognize that a to the 0, just like b to the 0, anything to the 0 power is 1, and so it kind of goes away, and that's why you don't really see the b to the 0 in the formula. So that's the pattern of it. Again, if whatever a is and whatever b is, that's going to change per problem. And if there happens to be a minus in the problem, the only difference is that the first sign gets changed to a minus and the last sign also gets changed. So it's minus plus minus. Now, let's actually apply it in some problems and see how useful you think it is. So this one here is, notice it's a difference of squares. It's A is 2x, B is 3, 1 is a plus, and 1 is a minus. So again, if you did this foiling, you would do first times first, outer times outer, inner times inner, and last times last. These would cancel, and you'd get 4x squared minus 9. If you remember the pattern that says it's a squared minus b squared, well, a is 2x, and b is 3. So it'd be 4x squared minus 9. And so again, the pattern's pretty important, and I would definitely use the pattern for these. So again here, because it's the first term is 4a, the last term is 5b, and it's a plus minus, then we're going to do an a squared minus b squared again here. So a is 4a squared, and then it's squared, and then b is 5b squared. And so when I do the math, it'll be 16a squared minus 25b squared. And again, it's a lot easier than foiling it and canceling the middle. Now this one here, this is a 6x minus 5 times a 6x minus 5. For me, I just think it's easier to foil these. Again, first times first, outer times outer, inner times inner, and last times last. And get 36x squared minus 60x plus 25, and there's my answer. Okay, now I'll do the other one using the shortcut. Remember that for this one, remember that the shortcut is a squared minus 2ab plus b squared. So in this case, a is 5, so it's 5 squared minus 2 times a times b, right? And the last one is plus b squared. And so when I do the math here, I'm going to get 25 minus 80x, and I'm going to get plus 64x squared. Or I could rewrite it as 64x squared minus 80x plus 25. Either way, that's the answer. If you memorize it, it's great. And if not, again, you could have just foiled it out and you would have gotten that answer anyway. We keep going again here. So again, now this is the same as 8x plus 3 times 8x plus 3. So I'm going to answer this one by foiling. So 64x squared plus 24x plus 24x plus 9. So 64x squared plus 48x plus 9 is my solution. And now I'm going to solve this one using the a and b. So the pattern for this one, again, remember, is a squared plus 2ab plus b squared. So a is 3x, b is 2. Oh, oops, I looked at this as being squared. So again, if I was doing it squared, that would be it. I do apologize. This is actually a cube problem. And so this one has a totally different one, right? So if I was to do this one the long way, what this is this is 3x plus 2 times 3x plus 2 times 3x plus 2. So again, I would have to solve this by multiplying two of these together first. So let me do these two, right? So I have 3x plus 2 times, and again, this is going to be 9x squared plus 6x plus 6x plus 4. And when I combine these two middle terms, I know that I'm going to get a plus 12x here in the middle. And so now I have to multiply this trinomial by this binomial. And again, I can use distributive property, or I could even use my box method at this point. If I choose the distributive property, I'm going to do 3x times 9x squared is 27x cubed. Then I'm going to do plus 36x squared plus 12x. And then I do the same thing with the 2. So 2 times 9x squared is 18x squared. 2 times 12x is 24x. And 2 times 4 is 8. And when I combine all my terms, I get 27x cubed plus 54x squared plus 36x plus 8. And so this becomes my answer for this problem. So I basically multiply two binomials, get that product, and then multiply that by the other binomial. Now, if I had remembered the pattern, and I'm going to apply the pattern to this second one, right? Remember that this one is going to be, the answer is going to be a cubed b to the 0, right? Minus 3a squared b to the first plus 3a b to the second minus b cubed. And so now that I know that pattern, I'm going to fill it in. Notice that a is x and b is 2, right? So I'm going to get x cubed minus 3 times x squared times b, which is 2, plus 3 times x times 2 squared, that's b squared, and then minus 2 cubed. So x cubed, here I've got minus 3 times 2 is minus 6x squared. Here I have 2 squared is 4, 4 times 3 is 12, so 12x. And then I've got minus 2 cubed, which is 8. And so if I did all the multiplying, it would be this. So if you notice, the pattern did help a little bit here, but I'm not so sure that it's that easy to remember this whole pattern. So again, it's up to you guys. The pattern or just multiplying it out all works the same. And then again, we just get to some more that are just complex, but again, it's really, this is just a binomial times a binomial. Again, on something this complex, I personally would use the box method or the area model. I like it. It's 3a squared minus 4b squared. I've got 3a cubed, and I've got plus 4b squared. Now notice again, this was a, oh, it's not really the same thing because it's 3a cubed. Okay, so yeah, so okay, I'm all set up. Now let me just multiply. So here I have 9a to the 5th. Here I have 12a squared b squared. Here I have minus 12a cubed b squared. And here I have minus 16b to the 4th power. So again, I'll just start out. I've got 9a to the 5th. And there's no common factors here, so it's minus 12a cubed b squared plus 12a squared b squared minus 16b to the 4th. And so that ended up being my solution. And then this last one here, again, you've got all these multiplied together. So I'm going to start by multiplying these two because they are opposites. It's a difference of squares. So this is x squared minus y squared. And notice here now you've got x squared minus y squared times x squared plus y squared. So again, it's a difference of squares again. So it's going to be the first term squared minus the second term squared. So it's going to be x to the 4th minus y to the 4th. And so that one was kind of tricky, but that one is one of those weird patterns again. And lastly, it says subtract this from this other one. So it's really going to be 2x to the 4th minus 10x cubed minus 4x. And you're going to subtract negative 7x to the 4th plus 5x squared minus 1 from it. So again, it's going to be, I'm going to rewrite it. And I'm going to have, you know, my 2x to the 4th minus 10x cubed minus 4x. And then I'm going to do minus negative 7x to the 4th. So that's plus 7x to the 4th. Minus a positive 5x squared, which is a negative 5x squared. And minus a negative 1, which is a plus 1. And then again, combine my like terms. So my x got 9x to the 4th. I've got minus 10x cubed. I've got minus 5x squared. I've got a minus 4x. and I have a +1. And again, very little that I could combine there. Very few like terms. So just be careful again, you know, understanding the difference between adding and subtracting. What do you do with those exponents? You do nothing with the exponents when you're adding and subtracting, and then you add them when you're multiplying.